Assalamu alaikum. Welcome back to BIOS course lecture number 10, which is about non-parametric test. Non-parametric test. In this lecture, we are going to study or to discuss the following points. So by the end of the lecture, students should be able to, number one, define a non-parametric test and discuss when it is appropriate to use the definition of non-parametric test. Number two, understanding the difference between parametric and non-parametric concept tests. Okay, understanding the difference between parametric and non-parametric test. Three, define the advantages and disadvantages of non-parametric methods. Number four, identify the non-parametric equivalent test to a parametric test. And number five, conducting a formal hypothesis test for difference between two or more population using Wilkinson sign rank test for matched pairs and Mann-Whitney test for independent populations and Kruskal-Wallis test for three or more independent populations. Let us start with the definitions. Number one, what we meant by parametric test. Parametric tests are tests that require assumptions about the nature or shape of the population involved. Again, in parametric tests, we require assumptions about the nature or shape of the populations involved. As you have seen in the previous lectures, okay, normality of the assumption of normality is a general or is required for all tests studied before. For example, for t-test, for normal test, for f-test, we have assumption. We have a constant assumption that data used should be normally or approximately normally distributed. So in parametric test, previous parametric test, we have or we need assumption about the normality of population. For non-parametric tests do not require such assumption. Okay, do not require such assumption of normal distribution. Consequently, these tests are called distribution-free tests. So the other name of non-parametric test is distribution-free test. Again, the main difference between parametric and non-parametric test is that in parametric test, we require assumption about the nature of the distribution of the population involved. Okay, this nature or this distribution should be normal distribution. For non-parametric test, we do not require that assumption of normally distribution. Okay, non-parametric statistical test. The non-parametric is not meant to apply such models. The term non-parametric is not meant to apply such model completely lack parameters, but that the number and nature of the parameter are flexible and not fixed in advance. This is general notes. Okay. The use of non-parametric methods may be necessary when data has a ranking but no clear numerical interpretation, such as when assessing preferences. The second point is that non-parametric methods are appropriate when we have data in terms of ranks, okay, and not real numerical interpretations. For example, when we have data on Likert scale 5 or 7 or 3 Likert scale, in this case it is preferable to use non-parametric instead of parametric test because the data are arranged in ranks and not real numerical numbers. Here we are going to see the advantages of non-parametric methods. Number one, non-parametric methods can be applied to a wide variety of situations. Why? Because they do not require normally distributed population. You know, in many cases, population or data used in analysis were not normally distributed. So in this case, we use non-parametric methods. The second advantage is that unlike parametric methods, non-parametric methods can often be applied to non-numerical data such as qualitative variables like gender, ranks, and so on. Okay, so we have two advantages till now. For non-parametric methods, do not require normal distribution. That why non-parametric can be used to for a wide variety of situations. The second is that unlike parametric methods, non-parametric can often be applied for non-numerical or categorical data. The third, non-parametric methods usually involve simpler computations than the corresponding parametric methods, and therefore easy to understand and apply. Okay, the third advantage is that it involves simpler computation. Disadvantages of non-parametric methods. Non-parametric methods tend to waste information, okay, because exact numerical data are often reduced to qualitative form. Okay, we will see this disadvantages when applying the test of non-parametric methods. Number two, non-parametric tests are not sufficient as parametric tests, are not such efficient as parametric tests. So with a non-parametric test, we generally need stronger evidence, such as larger sample or greater difference, before we reject the null hypothesis. Okay, again, non-parametric tests are not as efficient as parametric tests. Here is a table comparing parametric and non-parametric tests. For example, in the application of matched pairs or paired samples, in parametric test we use let's say t-test, okay, t-test for dependent or paired samples. In non-parametric test, we are going, for example, to see Wilkinson sign rank test. So Wilkinson sign rank test is the corresponding, okay, non-parametric test for the parametric t-test of two paired samples. Also, in two independent samples, okay, in two independent samples, also we use t-test for two independent samples. The corresponding non-parametric test is Wilkinson rank sum test. Wilkinson rank sum test is the corresponding non-parametric test for the parametric test of two independent samples, and so on. Okay, here we have the efficiency rating of non-parametric test compared, okay, to parametric test. You can see that all percentage or proportions of efficiency or rating are less than 1 or less than 100%. So all non-parametric tests are less efficient compared to parametric tests. Okay, this table is important. Okay, for any application you need to know the parametric test and the corresponding non-parametric test. Yeah, at least there is one non-parametric equivalent to each parametric general type of test. Look here, this is parametric test and equivalent non-parametric test. For example, describing one group, this is description. Okay, here you have description for describing one group. In normally distributed or parametric analysis, we use mean as a main measure of center and standard deviation as a main measure of variation. But for not normally distributed data, that means when using non-parametric methods, we use the median as the main measure of center in non-parametric analysis, and we use IQR, interquartile range, as a main measure for variation. Okay, this is for describing one group. For comparing two unpaired groups, two independent samples, we use t-test for independent, and we are going to see Wilkinson rank sum test. This is for two independent samples in non-parametric analysis. In comparing two paired, again we use t-test, and we are going to see Wilkinson sign rank test, which is the non-parametric test corresponding to the t-test for two paired samples. Okay, for comparing three or more independent samples, okay, we have seen before we use one-way ANOVA or F-test analysis of variance. This is for normally, okay, for normally distributed population. The corresponding non-parametric test is called cross-Wallis test. In coming lecture, for correlation between two variables, for parametric analysis, we use Pearson correlation, and for non-parametric, we use Spearman correlation. This table is very important. Okay, it summarizes applications, tests, or measures used for parametric test or measures used for non-parametric analysis. Okay, if the sample size is large and statisticians are not agreed on this extent of large. Anyhow, if sample size is large enough, regardless of the distribution, use parametric test. Okay, if sample size is large, okay, regardless of the distribution, use parametric test. Some statisticians said that large means more than 100 cases. Okay, others say that large means more than 50 cases. No agreement about what meant by this large. Okay, anyhow, we use parametric test when having large sample size regardless of the distribution, if it is normal or not. If sample size is small, the choice will depend on the distribution of data. Parametric for normal distribution, and non-parametric for non-normal distribution. Okay, in non-parametric test or non-parametric methods or non-parametric analysis depend on sorting, okay, on sorting the data into ranks, So a rank is a number assigned to the individual sample according to this order in the ranked list. The first item is assigned the rank of 1, the second is assigned rank of 2, and so on. Okay, after arranging a set of data from smallest to the highest. For example, if we have this original data set, this is the original data set. To assign ranks, we first sort the original data set from the smallest to the highest, from 3, 5, 10, 12, and 40. Then assign rank 1 for the smallest, for the first one, assign rank 2 for the second, and so on. Okay, these are the ranks corresponding to the real data in the original data set. Sometimes we have ties in the ranks, okay, or we have ties in the original data set. Look here, we have 3, 5, 5, 10, and 12. Okay, so we have two values with the same number. So we assign rank 1 for the first, which is 3. The second is 2. The third should assign rank 3, but because 2 and 3 are the ranks for the same value, we divide, or we obtain the mean of the ranks and assign the mean for each. Again, 5, 5, the first one is ranked, the rank is 2, the second assign rank 3. Okay, 2, 3 are ranks, but ranks for the same value. Find the mean of the ranks and assign the mean for each. So the mean is 2.5, so 2.5 is assigned for each. Then the next one is assigned rank 4, and the last one is assigned rank 5. This is what meant by handling ties in ranking. Now let us see the first non-parametric test, which is called Wilkinson signed ranks test for matched pairs. Again, the name of the test is Wilkinson signed ranks test for matched pairs, used for matched pairs. Okay, and you know, okay, for matched pairs means for dependent samples, or for paired samples, the same meaning. Okay, The Wilkinson signed rank test is a non-parametric test that uses ranks of sample data consisting of matched pairs, used for matched pairs. It is used to test for differences in the population distribution. This is the definition. Wilkinson signed rank test hypothesis. H naught, the null hypothesis, the matched pairs have differences that come from population with a median equal 0. And please take the hypothesis as it is, okay? It assumes that the matched pairs have differences that come from population with median equal 0. Median equal 0 implies no significant or difference or no difference between two populations. Alternative hypothesis, the matched pairs have differences that come from population with a non-zero median. And this is the alternative hypothesis. As I said, please take them as it is. Assumptions, very important. The first one, the sample data have been randomly selected, should be randomly selected. The second, there is no requirement that data have normal distribution, and this is the property of all non-parametric tests. No assumption or no assumption are required that the population should be normally distributed. For example, a study was conducted to compare the weights of students in September and April of their freshman year. Use sample data below to test the claims that there is no difference between the September and April weights. Here we have the weights in September and the weights of April for a sample of students. You know, this is matched pairs because we have two observations for the same case. This is student number 1, number 2, and so on. For the first students, the weight in September is 67 and the weight in April is 66, and so on. Number 1, state the non-alternative hypothesis. Number 2, find the p-value of the test. Number 3, based on the p-value, what do you conclude? Okay, you know, null hypothesis, the matched pairs have differences that come from population with the median equal to 0. H1, the matched pairs have differences that come from a population with a non-zero median, as it is. Next, we use jump to generate the outcome of the Wilkinson sign rank test. These are the steps in generating the outcomes of the test in jump software. Here is the output. This is the output. Okay. Forget about anything and concentrate only on this value. Okay. Okay. This side is about t-test, which is parametric. This is parametric, but now we are concerning with non-parametric. This is the non-parametric test. This is the outcome. The second value, okay, is the p-value of the test. This is the p-value of Wilkinson sign rank test. The p-value is calculated to be 0.043. The first value, don't care much about it, is the test statistics, okay? But now focus only on the p-value, which is 0.043. You know, this p-value is less than 0.05. This p-value is less than 0.05. So reject the null hypothesis. This is the decision. Reject the null hypothesis and concludes that September and April weights do not appear to be the same. Okay, this is a conclusion. Reject the null hypothesis and concludes that the weights of students in September and April do not appear to be the same. Again, this is the output of the Wilkinson sign rank test using JUMP software. This side is about t-test, which is parametric, don't care. The second part is sign rank test. This is the Wilkinson sign rank test. Look to the p-value, okay, and make a decision on the null hypothesis. Now, the second non-parametric test is called Wilkinson rank sum test. Wilkinson rank sum test. And please be careful, okay, to distinguish between the names, the first one and the second one. The second one is Wilkinson rank sum test, which used for independent samples. Okay, this is used for independent samples. Sometimes it's called Mann-Whitney test. Okay, this is common also. The name of Wilkinson rank sum test is sometimes Mann-Whitney test. Anyhow, this test is used for two independent samples, and you know this is a corresponding non-parametric test for the parametric t-test of independent samples. The definition: the Wilkinson rank sum test is non-parametric test that uses rank of sample data from two independent population. It is used to test the null hypothesis that the two independent samples come from population with the same distribution. That is, two populations are the same or identical. This is the key idea of the test. If two samples are drawn from identical population and the individual values are all ranked as one combined collection of the values, then the high and low ranks should fall evenly between the two samples. Okay. For me, this key idea is meaningless unless we manually calculate t-test. So just ignore about this key idea of the test. The assumptions: there are two independent samples randomly selected. Okay, each of the two samples has more than 10 values. This is the second assumption. For each sample, the values should be more than 10. And the third one, there is no requirement that the two populations have a normal distribution or any other particular distribution. Anyhow, the third assumption is general, okay, or constant in all non-parametric tests. No normal distribution required. Okay, we use JUMP, also JUMP software, to generate the outcomes. The questions are about what are the null and alternative hypotheses, identify the p-value, and make your decision and conclusion on the results. A sample of body mass index values of 13 men and 12 women used to test the claim that the median body mass index of men is equal to the body mass index of women. Here, we are going to test or examine if there is significant difference in body mass index between a sample of men and women using non-parametric analysis. I think the decision of using non-parametric analysis, because we have a very small sample size. Okay, we have very small sample size. Steps: state H0. The two samples come from population with equal medians, as it is. H1. The two samples come from population with different medians. Okay. Here are the steps of using JUMP software to run Wilkinson rank sum test. And here is the outcome of the results. Again, ignore about all the outcome and see only this probability, the last value here, this probability, which is the p-value of the test. This is the p-value of the test. Now, the p-value is 0.3409, which is greater than 0.05. So the decision is fail to reject the null hypothesis. Again, because the p-value of the test is greater than 0.05, we fail to reject the null hypothesis. So we conclude that it appears that body mass index of men and women are the same. Again, this is the output of Wilkinson rank sum test. Go to the last value, which is called prop of z, which is the p-value of the test. Compare the p-value of the test with 0.05. Reject H0 if the p-value is less than, and fail to reject H naught if the p-value is greater than 0.05. Now, the third test in non-parametric analysis is Kruskal-Wallis test. Kruskal-Wallis test. This test is used when we have more than two independent samples. So this is non-parametric test corresponding to the ANOVA, okay, or analysis of variance, which is a parametric test used in case of more than two independent samples. Also called H test. This is Kruskal-Wallis test definition. The Kruskal-Wallis test is a non-parametric test that uses ranks of sample data from three or more independent populations. It is used to test the null hypothesis that the independent samples come from population with the same distribution or with the same medians. Hypothesis H naught, the samples come from populations with the equal medians. And remember, the null hypothesis in the corresponding parametric F test is that mu1 equal mu2 equal mu3 up to mu_k. Alternative hypothesis, the samples come from population with medians that are not all equal. Okay, these are the hypotheses of Kruskal-Wallis test. Very important. We compute the test statistic, which is H, which has a distribution that can be approximated by the chi-square distribution as long as each sample has at least 5 observations. So we need assumption of at least each sample should have 5 observations. So the assumptions of Kruskal-Wallis are we have at least 3 independent samples, all of which are randomly selected. You see this is constant. Each sample has at least 5 observations, and we do not require a normally distributed population. Okay, using also JUMP, we have a sample of blood pressure. We are going to compare blood pressure at 8 m between 4 groups of those. So we have 4 treatments, 4 groups, 4 sample, and the objective is to compare blood pressure between 4 groups. First, state the null and alternative hypothesis, identify p-value, make decision and conclusion on results. So this is a null hypothesis. The samples come from population with equal medians. Be careful about stating the null and alternative hypothesis for each non-parametric test. H1, the samples come from population with medians that are not all equal. Here is the outcome of the Kruskal-Wallis test using JUMP software. Again, focusing on the last value. Okay, this is the p-value 0.361. This is the p-value. So 0.361 is the p-value, which is greater, this is greater than 0.05. So the decision is fail to reject the null hypothesis as the p-value is greater than 0.05. So the blood pressure appears to be the same across all those categories. Again, the last or the value or the prop chi-square, this value is a p-value of Kruskal-Wallis test used to make decision on the null hypothesis. Okay, here are some JUMP software exercises for reviewing the ideas of Wilkinson. Let's say Wilkinson signed rank test. This is the first one for dependent samples. Okay, here we use the file called reading study to test the significant difference in reading score between pre and post test. We have pre-test and post-test for the same students obtaining scores, and Let's use Wilkinson signed rank test to examine significant difference between pre and post scores. Okay, we need to state the null and alternative hypothesis, identify p-value, and make conclusion on the results. This is the null hypothesis, The matched pairs have differences that come from population with median equal to 0. H1, the matched pairs have differences that come from population with a non-zero median. Here is the steps of using jump. We need only the final outcome. We need the final outcome. Yeah, this is the final outcome or output of the jump. Okay, as I said before, this side is about t-test, which is parametric. Ignore. Look to the second side of signed rank and see the second value. Now, the second value is 0.0001, which is less than 0.05. So reject the null hypothesis as the p-value is less than 0.05. So post and pre scores appear to be different. Again, signed rank, see the p-value, compare the p-value with 0.05, reject the null hypothesis if the p-value is less than 0.05. The second exercise is about independent samples, and be careful. The test is called Wilkinson rank sum test in this case. Okay, we have a file of diabetes, and we are going to test the significant difference in total cholesterol level between males and females. We have two independent samples, male and females. So let's use Wilkinson rank sum test to examine significant difference in cholesterol level. Null hypothesis and alternative hypothesis, see the p-value and make decision on the results. This is at H0, the two samples come from populations with equal medians. H1, the two samples come from population with different medians. Here is the steps of obtaining the outputs of Wilkinson rank test in JUMP. And here are the output. Again, ignore about everything. Look only to the p-value, the probability, the last value. The p-value is 0.5597, which is greater than 0.05. So the decision is fail to reject the null hypothesis. Fail to reject the null hypothesis. It appears that the total cholesterol level of men and women are the same. Again, this is a p-value which is greater than 0.05. Fail to reject the null hypothesis. In general, the questions will be on the output. Okay, the output. So you need to know exactly the p-value of the output. Okay. The third case is about Kruskal-Wallis test. Kruskal-Wallis test is a corresponding to ANOVA. That means used for more than two independent samples. We use the file reading study. The file compare reading scores in pre-1 test across the three methods of teaching. Okay, so in this example, we have scores of students, and we have a variable called group. This variable consists of three different types or methods of teaching. So we are going to test if there is significant difference between the methods of teaching in terms of scores in exam. Again, the null and alternative hypothesis, the p-value, and conclusion on the results. This is the H0. The samples come from populations with equal medians. Be careful. This is the null hypothesis of Kruskal-Wallis test. The H1, the samples come from population with medians that are not all equals. Please take the null and alternative hypothesis for all non-parametric tests as it is. Okay. Here are the steps of Kruskal-Wallis test in JUMP. and this is the output. Okay, again, chi-square is a test statistics of cross-Wallis test. This is a test statistics 2.221, and the most important value is the b value, the probability, which is 0.3294. So the p value is 0.3294, and this b value is greater than 0.05. So we fail to reject the null hypothesis as the p value is greater than 0.05, and concluding that the pre-scores appears to be the same across all teaching groups categories. So the conclusion is that there is no significant difference between teaching group categories in terms of pre-1 scores. I hope this makes sense for you. Again, I'm going to upload more exercises for non-parametric test, and see you in the last lecture soon, inshallah. Assalamu alaikum.